All right, so we're going to go ahead and get started. Just as a reminder, keep your mics muted, please. I will ask questions at the end of each topic, and then if you guys have questions at that time, you can unmute, or you can always type in the chat box. David is going to be here tonight as well. He's another one of the tutors, so he'll answer your questions as well. Tonight, we're going to be talking about research, statistics, error, and types of research. And those of you that have been on the lectures before, you've seen this. This is just the consent to audio or video recording release. These are going onto YouTube. So if you're on here, just staying on means that you're consenting to this release. We put the URL down here, so you could also take a look on your own time if you'd like. If you want to change your last name, just in case it pops up, or if you want to change a profile picture or anything like that, now would be the time to do so. Okay, some basic information. This is the 15-week MCAT course. We're on week 14 now, so we only have 2 weeks left. There's the group me over there. Our Instagram handle is @SocraticMed_. Our YouTube page is right over there. I put the URL, so we have all of our videos on YouTube, the full lectures, and also sectional parts of each lecture. You can find those on our YouTube channel. And we've been doing 3 lectures a week, Thursday, Fridays, and Saturday at 8:30 p.m. Eastern. And our office hours are every Sunday at 8:30. So if you have any questions about any of the material that we did the past week, or any other question about the MCAT in general, you can stop by. Okay, so we're going to start with the basics of statistics. All right, so I don't anticipate this lecture being too long. This is more like supplemental information. There's not really too much research on the actual MCAT, but we'll go through some of the things that I thought were the highest yield in terms of this topic. So the measures of central tendency, I'm sure you've all learned them a bunch of times, but we're just going to go over them. The mean is the average of the sample. So the mean is calculated by summing all of the values in a set, in a given set, and then dividing that sum by the number of values in the set. So if you have a data set with 10 values, you add them up and then you would divide it by 10, and that would give us the average of all of the values. So remember, the MCAT will always give you numbers that can be manipulated easily without a calculator. So there is a chance that you may have to do some light math, especially on like the physics section. You may have to take an average or something like that. But anytime they give you math on the MCAT, it's something that you can either do in your head or something that you could do very, very easily with scrap paper. Because remember, you have it's sort of a notepad, like a white notepad with a marker, like a laminated notepad with a marker. So any sort of math problem that they give you, you should be able to do fairly simply. Mean is one of them. You're just summing and dividing. So the median is the middle value in the data set. It's the middle number in a set with an odd number of values. And it's the average of the 2 middle values in a set with an even number. So if you have an even number, then there's not going to be one specific value that's smack in the middle of both. So that would be considered like the 50th percentile. But if there's an even number in the set, there's only going to be 2 values right in the middle. So you would just have to average that, and that value that you get from that average would be your median. So because of that, the median isn't always necessarily a number that's part of the data set. But if you have an odd number of values, then it would just be the middle number. And the median is also known as the 50th percentile and the second quartile. And we'll talk a little bit more about percentiles and quartiles in a few minutes. So the mode is the most frequently occurring value in a set. That is exactly what it is. It's just whichever occurs most often. When I learned what mode was, MO, most often. If no value occurs more than once, then there's no mode. And if multiple values occur the most at the same frequency, there are multiple modes. So if there are 2 values in the set that appear 3 times each, and that no value appears more, then there would be 2 modes. And if there are no duplicates throughout the set, there would be no mode. Okay, so we're going to do just a round of a couple of review questions right now, just because this stuff can be kind of cut and dry. So I want to make sure everybody's on the same page. So I'll give you guys a minute or 2 minutes to do this. Just give me 1 second. Let me launch the polls. And keep in mind the polls are anonymous, so please just take your best guess, and we're going to go over it in a little bit. So, all right, polls should be live. Is anyone having problems seeing my screen? Okay. All right. Give you guys 5 more seconds and then we'll go over it. Nice. Okay, polls are closed. And thankfully, 100% of you said A. So A is in fact the correct answer. Yeah, it's just basic math. So I'm glad you guys got that right. 60, 60, 60, 180, 65 and 55 is another 120, which is 300. So 300 divided by 5 gets us 60. So that's really the kind of math that you'd probably see on the MCAT. They might be maybe a little bit more complicated, but you're not going to get anything super crazy. Okay, another question. Let me reopen the polls, take a minute, look it over. All right, you guys are good to go. All right, take a couple more seconds. I'm going to close the polls. So again, looks like 100% of you said 60, C, which is the correct answer. So remember median set, if you're trying to find the median of the set, you just have to remember to put them in ascending order. So we would reorder this from 55, 60, 60, 60, 65. And since it's an odd number, we would just do the middlemost number, which would be 60, and there's our median. Doesn't seem like anybody had any real issues with that, so we're going to move on to our last question of the set. So again, take another minute and we're just going to go over it and then we'll finally get on. So give me 1 second. Cool. Okay. Polls are live. Remember, they're anonymous. If you don't have the poll option in front of you, just go to your little toolbar, and if you hit the polls button, it'll pop up and you can answer that way. All right, give you a few more seconds. Okay. So again, 100% of you guys said 60, which is B, which is correct. So awesome. A group of 5 students, again, measured their heights for the class project. After completing the measurements in inches, they put values to the set. So for the mode, again, we're just looking for the most often, 60, 60, 60, it's 60. Pretty simple, but never hurts to review them. Okay, so moving on, measures of variability. The two that are most important are range and standard deviation. Again, a lot of the stuff that we're learning is you're not going to be explicitly tested on it on the MCAT. Like they're not going to ask you what a standard deviation is, but it's super important to understand. I think it's really helpful, especially when you're looking at normal curves, like over here to the right. So the range is the difference between the largest and smallest values in the set. In our last example, the smallest value was 55, the largest value was 65. So our range would be 10. It's just the difference between the two. It can help us identify how large the extreme values of a set vary, or how much they vary, or how large the actual set is, but it doesn't really tell us about the distribution of the values, which becomes more important when you have larger data sets with more values. When you do range, it doesn't really tell you anything about how they're distributed. If they're close to each other, if they're close to the mean, and that's where standard deviation becomes a little bit better of a measurement, because it measures the variability. It measures how far each value is from the set's mean. You don't have to calculate the standard deviation on the MCAT, but I just put the formula to the right, just so you're just a little bit familiar with how it's calculated. So all of this up here is just the summation of each specific value minus the mean squared. You just add all of those up, divide it by the total value, like the total amount of values in the set minus 1, and take the square root. Again, not super important, but I put it there. You should be able to just at least be familiar with standard deviation. And we have percentiles and quartiles. We spoke a little bit about them when we were talking about the median. So percentile is just the value at which n% of the data set falls below. So for example, at the 60th percentile, 60% of the data set is lower at that point. And often it's often used when reporting data sets that fall on the normal distribution, like we saw in the last one. This right over here, this sort of bell curve, is called the normal distribution. So I'm sure you've heard percentiles used, especially with test scores, especially with the MCAT. Usually when people ask you how you did on the MCAT, they're going to ask you, you'll tell them your number. You guys are going to say, oh, I got a 510, I got a 515, just like all of you are going to get. And they're not going to know what you're talking about. So you can say, oh, I scored in the 80th percentile. I scored better than 80% of the people that took it. Or I scored in the 90th percentile, means you scored better than 90 people who took that test. So that's what percentiles are. It's just you're at the level of everything else that's below you. Quartiles, it's just another, they're called quantiles, which are just measurements. So there's percentile, which is split into 100, obviously, for percent, and there are quartiles that are split into 4. So we have the first quartile at the 25th, the second quartile at the 50th, and then the third quartile at the 75th. So it just divides the data set. It's just another way to divide the data set. You should just know that if they're talking about the second quartile, they're talking about the median, or they're talking about the 50th percentile. And yeah, like we said before, the median is the 50th percentile, and it is also known as the second quartile. They're all talking about the same thing. And we got one more review. So we're going to go back to that same example of the students measuring their heights for the class project, same data set. So a little bit different of a question. Take a look. I'll give you guys about a minute, 2 minutes, and then we'll discuss in a little bit. All right, I'll give you guys another 10, 15 seconds to get your answers in. Remember, all the answers are anonymous. All right, so 100% of you said C, which is awesome. Good job. So a group of 5 students, I'm not going to reread that again. So the number 60 would not be considered which of the following? Second quartile, which it is because we know that 60 falls right in the middle. 50th percentile, same thing. Median is the same thing as the second and 50th percentile. So the 100th percentile is not 60. In this case, the 100th percentile would actually be 65. So good job. Can everyone see my screen?
Yes.
Okay. Okay. All right, cool. So types and methods of research. We're going to talk a little bit about the different types of research that you'll encounter on the MCAT. But first, we'll talk a little bit about error and bias and how we can avoid it. So when conducting controlled research, it's important to take steps to reduce error and bias. It's really impossible to avoid them, but we take steps to control them so that we can get the most accurate results. So an experimental study should be double-blind and randomized controlled. 2 terms, if applicable, they help to reduce this error and this bias. So a double-blind experiment eliminates, that should say, any subjective bias the subject or the researcher may carry. Neither of the two know if they are administering to the control group or experimental group. So normally in an experimental setup, especially if you're talking about like a clinical trial, you'll have 2 separate groups. We'll have the control group. They're probably getting the current standard of care. So if we're talking about, say we're talking about a new flu vaccine that's on the market, the control group would have the best flu vaccine that's currently on the market, and the experimental group would have the new vaccine that is trying to get FDA approval. The double blind means that neither the subject or the person that is administering the vaccine knows if it is a control vaccine or an experimental vaccine. So that eliminates bias from both standpoints, because you can have bias on both standpoints. If the subject knows which is which, the expectations could skew the results, and it's the exact opposite. If the person administering it knows, they could be giving, verbal or nonverbal cues, things that are tipping off the subjects in those 2 different groups. There are a number of ways that the study could be affected negatively. And a randomized controlled experiment is just one in which the experimental and control groups are picked at random. So that eliminates like sampling errors. FDA trials use the current standard of care as a control group. If the new treatment cannot be proven statistically better than the current standard of care, it may not get approved. So that's one of the hallmarks of FDA approval and testing. And we're going to go a little bit into the different types of studies that they'll talk about. They talk a lot about studies like this on the Psych and Soc the section. So you might even encounter some passages regarding studies like this. So case study is a type of observational study where the researcher follows a specific individual with a remarkable or unusual condition. So you're following one individual through time, and you're sort of just taking their account of, say, a disease or some sort of condition. It's not really an experiment where we're trying to establish a cause and effect relationship, or we're even trying to find statistical significance. It's just a case study. It's just an observational thing where we are watching this study and we're just gathering information from our observations. So it's great to use for like future, like to spark more questions and to guide future research, but it doesn't definitively or conclusively provide results. It gives insight and it sheds light on the lesser studied conditions. So I'm sure you know about a bunch of different case studies. Sybil, if you've ever heard, was one case study that was pretty popular in mainstream media. She had reported conditions of dissociative personality disorder. So that was one case study of the 20th century. I think it was later proven to be kind of not valid, but It's a popular example. Case control study is a type of study where the researcher takes the subjects with the remarkable condition, so the person that we are watching with the case study, and matches them with a negative control subject. So that would be if we are trying to study how life is affected by someone with a rare skin disorder. Instead of just doing a case study on that person and how that person navigates their environment, we would then find a control group, maybe someone who lives a very similar life to this person, everything except that disorder, and we would compare the two, and we could draw a little more insight maybe about how specifically the study, how specifically the condition is affecting the life of the person. But just like a case study, it can't really provide concrete evidence because we don't really have a large enough sample size to provide statistical significance. So moving on, we have cohort study, which is a longitudinal study that follows a group of individuals, which we refer to as a cohort, and samples the data through time. So it's kind of like a case study, except we're looking at a group of people now. It's a cohort study. And longitudinal just means that we're following the same data of interest throughout time, the same set. So it could be we're following a cohort throughout time. The case study means we're following an individual throughout time. Those are longitudinal studies. Longitudinal meaning long through time. So cohort studies can be useful in establishing cause and effect because we're watching their actions play out in real time, but they can be expensive and they can be time consuming. So it's very difficult if you have a large cohort, if it's about a couple of hundred or a couple of thousand people, the more people you introduce into it, the more possibilities for error it is. You have to pay them more. It's time consuming because you have to check in with them. Subjects sometimes might not be super consistent with what they're asked to do or with what they're asked to report. Sometimes they'll drop out before the study ends. So all of this contributes to the uncertainty of the final. But I mean, they can be useful if they're done correctly. So we have correlational studies as well, which is a study that provides evidence for the association between two variables. So if you look at that picture at the bottom, it just shows three different types of outcomes you would have for a correlational study. R is the correlation coefficient. So if it's a positive number, that means that they are positively correlated. If it's negative, they are negatively correlated. And if it's close to zero, it really means that there's no correlation at all. And you can even see it on the graph. So the closer that R gets to -1 or 1, the stronger the correlation becomes. And when you're talking about correlation, it's very important to remember that correlation does not prove causation. So you have two variables that are occurring at the same time, or that one is increasing and one is decreasing at the same time, but we don't have enough evidence just from a correlational study that can prove one is causing the other. So if we just see that two of these variables are increasing over time, it's impossible to prove causation without an experimental setup. It's just saying that these two things are happening at the same time. One could cause one, vice versa, or an outside factor could cause both of them. And as we said before, R is the correlation coefficient, and it can tell us if the correlation is positive or negative, or if there is one at all. So it's not, correlational studies are not used for cause and effect discovery. It's just used to find associations between two different variables, which can be extremely helpful in and of itself. So we have cross-sectional studies, which are studies that sample data from a population at a given point in time. Cross-sectional studies may utilize different samples at different points in time to collect data, whereas longitudinal studies would follow one sample across time. So if we are conducting a longitudinal study about the skin disorder that we were talking about, we're probably going to see that there's a progression of this disease. Maybe it starts out very mild, and then 30, 40 years later, it gets very advanced. So a lot of times in medicine, we'll split it up into stages. A longitudinal study would follow this cohort along the different stages, whereas a cross-sectional study, we would get a group that's in stage 1 of the disease, analyze it. Group 2 of the disease, analyze that. Group 3, all at the same time. So that's why we're calling it cross-sectional rather than longitudinal, because we're not following it through time. We're sort of just stratifying it based on the progression point of what we're interested in studying. And survey is a research method used on human subjects as a way to extract subjective data about one's experiences or opinions. So I'm sure you've all participated in surveys. Some of you might have even conducted surveys. We're just gathering subjective opinions and experiences. So when reporting, subjects may introduce error into the data if they are not completely truthful. Obviously, there are some studies that have shown that when it comes to certain topics, people will under or over report certain behaviors, certain ideologies, stuff like that. And though the respondents' answers are generally regarded as true, small inaccuracies can lead to large errors during data extrapolation. So it's important to keep that in mind that when you're looking at surveys, if you're trying to extrapolate, which means you're trying to create new data and make new interpretations based on what you have, you do have to take into consideration that a survey is only as accurate as the people that are answering it. So experimental studies, which is a general type of study that a few of the ones that we've talked about already probably fall into the category of. But these are just the studies that establish cause and effect relationships between independent and dependent variables. So we said before, correlational studies cannot establish cause and effect. If we find from a correlational study that there's an association between two variables, then we can set up an experimental study. A lot of times correlational studies are quicker and easier because it's usually just taken from a pool of data that we already have, and we can see that there's an association between these two variables. And then once we can see that, we can plan and design an experimental study to actually analyze the cause and effect relationship. We might find that one causes the other, or we might find that a completely different thing causes the two, that they don't have a cause and effect relationship between each other. So the independent variable in the experimental study setup is what the researcher is manipulating, and it's conventionally graphed on the x-axis. So the dependent variable is what we're interested in seeing change, and it's graphed on the y-axis. So that's what's actually changing and what we want to see change. So for example, if we're trying to see different sports drinks would make seeds of a plant grow faster than water, we would set up multiple pots maybe, and we would feed them different sports drinks. We would maybe have a control group with water. The type of sports drink would be the independent variable because that's what we're manipulating. That's what we're manipulating to try to find a different outcome. And the different outcome that we're trying to find is the growth, which we can measure in the height of the plants. So the height of the plants would be the dependent variable. So the dependent variable depends on the independent variable. We're changing the independent, and the dependent will change accordingly, or will not change accordingly if there's no relationship. Yeah, so definitely know the difference between independent and dependent variables for the MCAT. We have clinical trial studies, which is a type of randomized group experimental study that compares a new intervention or treatment to a placebo or current standard of care. So like other experimental studies, clinical trials can establish a cause and effect relationship. So clinical trials obviously are done for FDA approval. And FDA approval, the way it goes clinically for the clinical phases are broke down into 3. Before they even get to the clinical phases, they test on animal models. And if it seems effective and safe, then they start phase 1. Phase 1 studies the safety, dosing, and metabolism of the drug in a small group. So it's normally about 20 to 80 people. They'll try it on, different diagnoses they'll try it for, and they'll see if it works and if it's safe. Once it passes phase 1, I think about a third of all of the experimental drugs that get to phase 1 actually pass it. Once they make it to phase 2, it's a study for the efficacy of the drug compared to a control group with a slightly larger group of people. So now after we move from phase 1, we're studying actually how well the drug works. So it's a little bit bigger of a group, and we have a control group now. And if it seems like it's actually doing more than the control group, then it moves on to phase 3, which is the statistical significance trial. So this is hundreds, usually thousands of people, and the studies are being done on a large scale. And the control group, again, is the standard of care. So we increase the group because we're trying to prove statistical significance now. We increase the sample size. So if it is statistically significantly better than the current standard of care, it moves on to the next phase, and it will probably go on to be approved as a new drug. The entire process can take several years to complete, and very few experimental drugs will actually make it past all 3 phases. So years. It could take like 5 years, 7 years. But it's good to have some background on how that works, because I've seen it talked about. I mean, you never know what's going to pop up in your interviews when you get when you get to applications. Okay, so we're going to review again. Take a minute, read this. Give me 1 second. Let me relaunch the polls. All right, they should be live. Remember, if you're just joining us, that all of these polls are anonymous. Just click the poll button on your toolbar. It'll pop up. Just take a guess. I'll give you a few minutes and we're going to go over it. All right, take another 10 seconds, get your answers in. I'm glad to see I finally stumped you guys. Okay. All right, so 25% of you said A, no one said B, 25% said C, and 50% said D. So 50% of you did get it right. The correct answer is D. So let's go over it. A student in a high school chemistry class is watching and recording the half-life of a substance by recording its relative concentration in a solution using a spectrometer. So the student observes that without interference by other factors, the concentration of the substance is cut in half approximately 8 minutes after the start of the experiment. Identify the dependent and independent variables in this experiment. So remember, the independent variable is what is being manipulated or what is changing, and the dependent variable is what is changing because the independent variable is being manipulated. So the dependent is what we're interested in seeing change. So the student observes, is watching and recording the half-life of a substance by recording its relative concentration. So when we're looking at this study, we're going to be looking to see how the concentration is changing, because that's what a half-life is. It's how long a substance will break down into 50% of its original. So if it takes 8 minutes for 50% of this substance to remain, its half-life is going to be 8 minutes. So how do we tell that? We take the starting concentration, and then once it gets to half that number, that would be the half-life. So we're just recording the concentration change throughout. So the concentration change really would be the dependent variable. So let's look at A, the dependent time independent substance concentration. Time is not a dependent variable. Time is never really a dependent variable. If someone ever finds a way to make it a dependent variable, then please let me know. The B, dependent light and independent time. Time is definitely an independent variable, but we're not really doing anything with light in this study. It's possible that light could affect the half-life, but it was not mentioned in the question, so you shouldn't pick that. C, the dependent is substance concentration, and the independent is light. Substance concentration would probably be a good guess for the dependent variable, but independent, again, light, We didn't really mention anything about light in the experimental setup, so I wouldn't choose that. But D, the dependent substance concentration and the independent is time, is the correct answer, because we're looking to see how substance concentration is changing over time. So another way to do this is that if you think about what the graph would look like, pretend you're conducting this experiment, and then at the end of the day, you have to hand in a graph with your results. What you would be doing, your graph, you would set up concentration on your y-axis, and you would set up time on your x-axis. You would draw the line plot, and then wherever it was at 50%, you would find the time, and that would be your half-life, and that would be your answer. So time is on the x-axis because it's the independent variable. The dependent is substance concentration. It would be on the left, probably be in molar, and that's your dependent variable on the y-axis. Is that clear for anybody? Does anybody have any questions? You can use the chat box or you can unmute. Cool. I know dependent and independent does tend to confuse a lot of people. It's not even the concepts, it's just keeping the two straight. But you definitely should definitely have those under your belt before you take the MCAT.
Why is time there?
Okay, inferential statistics and hypothesis testing. So statistical significance. In order to prove a relationship between two variables, we set up experiments and interpret the data to look for statistical significance. So that's what the third trial, phase 3 and FDA testing aims to achieve. That's why there are thousands of people, because the larger sample size, the more reliable the data. When a relationship is proven statistically significant, this means that our result is most likely due to some factor other than chance. So for example, if we want to prove that the girls in third grade class performed better on their last test than the boys in the same class did, it would not be enough to take the average of the two subsets and compare. So if we take all of the grades of the girls in the class and we average it and say it's an 85, and we average all of the boys' grades in that same third grade class and it's an 84, that alone would not be enough to definitively say that the girls performed better than the boys. Because it's not statistically significant. It's not proven. So what we have to do is run it through different statistical analyses. And for this specific example, to eliminate the role of chance in this situation, we would compare the means of the two groups using an unpaired t-test. So the t-test unpaired t-test would just be comparing two averages, like the 84 and the 85, and we're just doing a statistical analysis on it and seeing the likelihood of it being up to chance, or if it actually is that the girls did better than the guys. So to do this, we choose an alpha value based on how confident we want our results to be. So for 95% confidence, we would choose an alpha of 0.05, because the confidence is 1 minus alpha. Alpha is 1 minus confidence. So if we choose an alpha of 0.05, whatever we get, we'll get either the result is statistically significant or it's not statistically significant. We can say that with 95% confidence if we chose an alpha of 0.05. And we could say with 99% confidence if we chose an alpha of 0.01. So alpha becomes important because when we do our t-test, it spits out a variable known as p, and we take that p-value and we compare it to alpha, and that lets us know if it's statistically significant. So once we choose the alpha, say for 95%, we're going to choose that 0.05. We can run whichever test fits. So an unpaired t-test in this case would be the best example. And you do not have to know the statistical tests. You don't have to know which test works best in which situation. Definitely out of the scope of the MCAT. But you should know that a t-test is a very common statistical analysis that's used, especially when we're comparing averages. So like it's used a lot in biology and stuff like that. But we generate that p-value that I was just talking about. The p-value is the likelihood that we could get these results under the assumption that the null hypothesis is true. So basically what that means is it's just how likely these results are by chance. That sounds a little bit confusing, but all you have to know is that if the p-value is less than alpha, then that's a good thing. We proved it right. So there are two different types of hypotheses. Whenever we have hypothesis testing, in this case, we're going to set up two different hypotheses. So either the null hypothesis is true or the alternative is true. So in this case, our null hypothesis would be there is no statistical significance. There's no difference between the two tests. If they took that same test again, then the boys would probably score more than the girls. It was due completely to chance. That was the null hypothesis. The alternative hypothesis is that the difference in these averages is not caused by chance, and the girls are actually performing better than the guys. So if the girls took the test again, then they would most likely, we would say with 95% confidence, they would score higher than the boys again. So that would be the alternative hypothesis. So if we use an alpha of 0.05 and our unpaired t-test gave us a value of 0.043, that's a good thing because our value is smaller than alpha. So we would say that with 95% confidence, the girls in the class outperform the boys because p is less than alpha. So in this case, we would reject the null hypothesis. So remember, the null hypothesis is there is no statistical significance. So because p is less than alpha, we would say that we reject the null hypothesis and the alternative is true, which means that we just proved a statistically significant relationship. Okay, and a little bit more on that, just testing errors. So I'm sure you've heard of maybe false positives and false negatives. This has especially been in mainstream media regarding COVID testing because there are a bunch of new tests that are coming out, new companies putting out different tests. So we look at the false positive and false negative rates. So type 1 error is also known as a false positive error. So that occurs when a true null hypothesis is rejected. So remember when I said the alternative hypothesis, we're proving a statistical significance. So when we reject the null hypothesis, we're proving that there's statistical significance. If a type 1 error is committed, that's a false positive. So we should have accepted the null hypothesis, but we rejected it. And it's represented by alpha. And remember that our confidence value is represented by 1 minus alpha, which is 90% in our test score example. So this is why the smaller the alpha, the larger the confidence, the more likely it is that our data is statistically significant. Because 95% confidence is good, 99% confidence is even better. So that p-value is going to have to be even smaller because our alpha is going to be 0.01 with 99% confidence. And it makes sense that it's more confident because our false positive rate is smaller. Alpha is going to be 0.01 instead of 0.05. So there's even less of a chance that there would be an error committed. And type 2 errors are false negatives. Those occur when we accept the null hypothesis when it's false. So if we predict that there is no statistical significance when there actually is, and that's represented by the Greek letter beta. So that's like alpha, and then confidence is 1 minus alpha. Beta is beta is type 2 error rate, and then 1 minus beta is the power of the study, which is the probability of correctly rejecting the null hypothesis. So the power is just another factor that we can look at to gauge how accurate the study is. So similarly to type 1 error and the confidence relationship, as the power of a study increases, the chance of a type 2 error occurring is reduced. So the more powerful a study is, the less likely a false negative would be, which is super important in regards to like COVID testing, because some would argue that false negatives are a lot more dangerous than false positives, especially if you're working in some sort of surgery practice or something like that. So I work in a surgery practice and we do endoscopies and we do a lot of open mouth procedures. So throughout COVID, when these rapid machines were just coming out, there was a lot of worry about a false negative rate because false negative rates are so much worse than false positives. If it's a false positive, we would just send them home, put another specimen to the lab, and then we would get a negative result and everything would be fine. But if it's a false negative, you could have a potentially positive patient undergoing an open mouth procedure with people in the room. So a lot of people would argue that false negatives are much more important to pay attention to. The null hypothesis is just the hypothesis that nothing changed. So if we have our two values, if we have our two averages of boys in the class performing on the test and girls in the test, the null hypothesis just says that they performed equally. The alternative hypothesis would say that one performed better than the other. The null hypothesis is always just no statistical significance, no change. Because there's always going to be two outcomes whenever we're testing something. It's either going to be the expected outcome or it's not going to be the expected outcome. So the null hypothesis is just the outcome where there's no statistical significance.
Hello? Can you hear me?
Okay. A little bit more on reliability and validity. So reliability is the degree to which an assessment produces consistent and replicable results. And there are two types of reliability. So there's test-retest reliability, which is the reliability of the assessment tool. So say the assessment tool is an exam. The same student being assessed 5 times should find similar results each time. So that's sort of the concept of standardized tests. When people say you bottom out on a standardized test, you're only going to increase to a certain amount and then you might get stuck. Or if you take the same test 5 times without studying even more, if it's a reliable test, you're going to score around the same time every time you take it. Inter-rater reliability is how much do different researchers agree in their assessment. So that could be, say, if we're going back to the testing example, if it is a subjective scoring, say they're scoring an essay, the rubric, the reliability of the rubric, 2 scorers should have similar results for reading the same essay. We have the validity, which is the degree to which the results of a study are truly accurate. And there are 3 types of validity. So internal validity is how much the results of the study actually represent the causal relationship between the 2 variables. So basically how much the results actually are telling us what we want to know. External validity is how accurately the results can be generalized to other situations. So maybe if we're doing a clinical trial about a vaccine, how well can we generalize these results to a situational sort of concept? So like how well will they actually perform in the field as compared to being performed in a lab? And construct validity is the measure of how accurately a measuring tool is collecting the required data. So measuring tool meaning your methods, your methodology, how well your actual experiment is collecting. So are survey questions the best method for a study, for example? Maybe the specific study would be better suited for some sort of observational study rather than surveys. So you don't have to memorize these, but definitely be familiar with them. All right, review time. I will give you guys a few minutes. Remember, polls are anonymous. If you can't find the polls, go up to your toolbar, click that polls button. And give me 1 second. I'm going to launch the polls again. All right, take a few minutes.
I have a question.
Sure.
So maybe I saw this wrong, but to my understanding, you taught us the trends for unpaired t-tests. This question, the t-test is paired.
Mhm.
Do the same rules apply here too?
Same. Yep, same exact rules. It's always, the rules are going to apply for any sort of statistical test. It could be a t-test, it could be a chi-squared test, or a bunch of tests that we don't even care about. It's the same rules. When p is lower than alpha, it is significant. There's a significant difference. Yep. All right, I'm going to close the polls in 1 second. Okay. So 100% of you said C. The correct answer is B, however. So we can definitely go over this. A researcher is hypothesizing that a group of students would perform better on a test in their own classroom than if they took a similar test in a different classroom. She calculates the average test scores in both environments and runs a paired t-test, which gives her a p-value of 0.04, which of the following is false. So if you're given the p-value, that's like the hardest part. So when you're given the p-value and you're given the confidence or the alpha, all you're doing is comparing the p-value to alpha. So if p is less than alpha, there's going to be a significant difference. So we have p equals 0.04. Let's look at A. There's a significant difference between test scores with 95% confidence. So our p again is 0.04. 95% confidence, remember, alpha is just 1 minus that. So our alpha for that is going to be 0.05. So p in this case is less than our alpha. So there is a significant difference. So that statement is true. So that's not the correct answer. And just by that, 100% of you said C, but just from that logic right there, you can eliminate C, because C says there's no significant difference for any confidence level. But at the 95% confidence level, we do see a significant difference. So A and C are incorrect. And D is there is a significant difference between test scores with 90% confidence. So with 90% confidence, our alpha would then be 0.1, because we're doing 1 minus 90%, which is 0.9. So in that case, our alpha would be 0.1, which again, P is a lot less than that one. So there's definitely a significant difference with 90% confidence. Does that kind of make sense? Does anybody want me to explain that again? Explain it in a different way?
Chris, can you hear me?
Yes.
Yes. How about A? What's wrong with A? You said compare the p-value to the alpha, and if p is less than alpha, then it's significant. But
Yes.
What's the confident? I got the significant part, the first part, but the confidence is what now?
So confidence with 95% confidence is just how they would just give you that so that you can get your alpha. So 1 minus confidence is going to be alpha. So because we have 95% confidence, you know that your alpha is 0.05. You compare P to that and you see that P is less. So you know that there is a significant difference between the test scores, but the question asks for which of the following is false. So A is not correct.
No, I didn't get that. So the alpha is 1 minus 0.04 because, or 1 minus, what's the alpha?
Alpha is 1 minus 95%, 1 minus confidence. So if you take that confidence level would be 0.95 and you add alpha, it's always going to equal 1.
So 1 minus 0.95 is 0.05.
Yep, and that's your alpha value. So that's the value that you always take if you're talking about hypothesis testing. You take that value and you compare it to the p-value. So we would perform a bunch of like statistical analyses and it would give us this value of 0.04. So we can compare that to our alpha. And if it's less than our alpha, then that means our results were significant. But we can change our levels of confidence. So with
0.05 is greater than 0.04. So what does that mean?
So that means that there is a significant relationship.
Oh, that's all that means.
Yes.
Confidence was given. Okay. All right. Got it.
Yeah, no problem. Yeah, so you can change the confidence, and you notice that as the confidence increases, when we go from 95% confidence to 99% confidence, our alpha decreases. So it'll go from 0.05 to 0.01. So now with 99% confidence, that same p-value 0.04 is greater than our alpha now. So we cannot say that there's a statistically significant relationship between the two. There's not a significant difference between the test scores with 99% confidence. We can say with 95% confidence because it gives us a higher alpha value, so there's more wiggle room.
Can I ask a question, please?
Yeah, absolutely.
So when I first read this question, I thought both B and C are false, and that's why I couldn't even, choose an answer on the poll. I understand why B is false because 0.04 is greater than 0.01. But for C, it's saying there's no significant difference for any confidence level. I mean, there's clearly a significant difference for the 95% confidence level and the 90% confidence level. So wouldn't that be false as well?
Wait. Yeah, you might be right. Hold on. Yeah, you're absolutely right. Yep, C is also correct. Yeah. Cool. Good catch. I love that you're paying attention like that. I'm gonna fix that before I get the. I'm gonna fix that before I.
Okay, why is C correct now?
Because it says there is no significant difference for any confidence level, but we just said that there is a significant difference for the confidence level for A. So I misworded that. It should say it should be worded differently. I confused my own negatives. But yes, that is absolutely correct as well. Okay, cool. Okay, so we're going to move on now. We're pretty much done. There's just a couple of other things that I wanted to talk to you guys about really quickly. So should you read scientific literature for the MCAT? Some of you may have heard that you should. Some of you may have not, and some of you may have not done a lot of time. I do think reading scientific literature is a good idea to help you prep for the MCAT. If you are studying in advance, then you should be able to map out some time. So like reviewing scientific journals and studies is a great way to familiarize yourself with terminology and experimental setup. So if you have never really read scientific literature in school, then I would definitely encourage you to be familiar with how to attack it. There are articles online, they'll help you analyze it. It'll break it down the different parts, the different sections that you would find in scientific journals. And although you're not going to be directly tested on your ability to comprehend scientific literature, reading it could definitely help your comprehension skills for any passage-based questions. So that's for cars, anything that you might come across in the biochem section as well, especially the cars section though. Just reading and being familiar with the terminology and not being blindsided when you get to the MCAT, like for certain words or maybe the way passages are structured. I think it's definitely worth incorporating some sort of scientific literature reading into your study. Reading scientific literature will also just improve your knowledge content, and you should definitely pick topics that interest you. So you're going to be learning, obviously, how to comprehend from the passage, and you're going to familiarize yourself with the terminology, but you're also going to be learning about the topic and the subject. So it's another way to really improve your content base. So I definitely do think it's worth your time. You don't have to devote too much time to it, maybe like an article a week, an article every 2 weeks, something like that, because it also keeps your brain sharp, maybe even on like an off day or something. And there's this really cool website that I've heard from a couple of people called 2 Minute Medicine. It's a really great resource for breaking down scientific articles. You can join for free. And what it does is it basically takes a bunch of popular scientific articles and it breaks them down. It summarizes them. It'll maybe break down the different parts. So I do recommend using it. I recommend finding an article that interests you. Try to read the full article. You can go onto 2 Minute Medicine and it will link you to the full articles. Some of them you do have to pay for. Some of them you should be able to find free versions of them. So it's really good. It'll help you review the article. So I'd recommend maybe finding one, reading it completely, breaking it down by sections, putting it in your own words, like what is the discussion section talking about? What is the abstract talking about? The conclusion section, methods, all those different sections, try to summarize them, try to, in your words, say what they're talking about, what the major points are. And then after you think you understand it, you can go back onto 2-Minute Medicine and read their summaries. You can compare, verify, see how on topic you were, see maybe how off topic you were. And I do think it'll help reading comprehension. I think it's a useful tool. So if you can fit it into your studies, I definitely recommend it. It can only help you be more well-rounded. And it'll also give you some really cool things to talk about in your interview. And that is all I have for today. Have an awesome weekend. Happy Friday, everybody, and come to office hours on Sunday. If you guys have any questions, I'll stick around for a couple of minutes, but other than that, we are finished for the night. So thanks so much for joining. I will post the PowerPoint in the GroupMe, and the video will be on YouTube shortly.
Chris, just one question. Could you go back to that experimental slide, please? The one about experimental studies.
This one?
Yes. Those variables. The type of score trend. Okay. All right. And you said time is never dependent. And why is that? Just why is time never dependent? Time is never. What
time is never dependent because the dependent variable is what is being changed by something else. So nothing can really affect time. So if you try to imagine like a graph where time would be on the y-axis, it doesn't really work. Time is changing every other thing, but we can't really manipulate time. So
okay,
yeah,
right.
That's pretty much it.
We can't. It can only go forwards.
Yeah, exactly.
A certain extent. Okay.
Yeah.
All right. Let me see. Is that the question I had? The deep. Yeah, I think that's the question I had.
Cool.
Okay.